Hi everyone, Dennis Foley from Acoustic Fields. Today we're going to talk about frequency, amplitude, and usage. Frequency, it's kind of our definition of the cycle of the wave or wavelength, or the ray, so to speak, that we're looking at. Amplitude is strength. So let's try to keep those terms in mind. And then when we take frequency and amplitude and we put them in a room, all kinds of crazy things happen. They're fine on their own in free space. But when we confine them to a room, it's like putting a bull in a china shop, especially for low frequency energy. So we take frequency and amplitude and put it in the room. Most of the frequency and their associated strengths won't fit. Really won't fit. So then we get all of this pressure build up in the room. And then that pressure creates a map, so to speak, of our room. So depending on the width, depending on the length, and depending on the height, our map will look different. So let's take a kind of an off-the-cuff example here of a room, and we're looking at the modal pressure builds up in the room, and let's just treat the sidewalls in this rectangular room. 30, 40, 50, 60 maybe on one sidewall, 40, 60, 80, 30. Different locations. You know, we can see here we have opposite situations going on. Here we have a little different situation going. Here we have a number that's not even present on the other side. So the bottom line here is, depending on the width, depending on the height, depending on the length of the room, and depending on how much energy you put in the room, you're going to get a pressure map. And it's going to have the frequencies laid out at the room boundary surfaces, even inside the room. We could have 40 in here, we could have 30, we could have 60 over here. When we did our measuring in rooms like this, we used 18 microphones, and we placed them every 3 feet throughout the room. If we had to move the grid because the room was larger, we did, but we kept that 3-foot standard. So nothing could hide. And what we found in our measurements by monitoring amplitude was that room modes, usually in small rooms, below 4,500 cubic feet, exhibit this 3 to 4 foot area that they're causing problems. Now, it could be 3 to 4 foot in width, could be 3 to 4 foot this way. This depends on the floor to ceiling dimension, the side to side dimension, and the front and the rear wall. So everything is dependent. So what you have to realize is, and this is one of the reasons for people like to claim Helmholtz resonators, because they can map out the room, find the particular frequency and amplitude of the problem in the room, build a Helmholtz resonator, and place it in that position. The problem is, you can see you'd be building a lot of resonators, and you have a lot of them in the room. You can do it. I've seen it done. But there's better ways with broadband diaphragmatic, and that's the technology that we use. So always the critical factor: type, amount, and position of treatment. Once you quantify and qualify your problem, it's easy to find that, well, it's not so easy, but we have solutions that can help you with those particular frequency ranges. So hope this helps. Frequency and amplitude usage, pressure mapping of the room. Know that your problem is not the same everywhere in the room. Thank you. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that, because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple of days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.